Your hair is perfect.
I am such a girl, it's terrible.
How are you doing today?
I'm great, thank you. I'm really excited about our guest this morning. I've been in love with outer space since I was a kid. I was fascinated by I'm that old that I remember the Gemini missions. I remember John Glenn going around the Earth for the first time. I remember when then the Soviet Union was sending dogs up as well as people. And I remember staying up with my dad to watch The Man in the Moon. I actually had a cheap back of a comic book telescope that I paid, I don't know, 10 cents for. And so as soon as I got into journalism, I thought, well, now's the time that I can meet bona fide astronomers who will answer all my questions. And thus I came into contact with the amazing Gary Boyle, the Backyard Astronomer. He also has appeared on just about every show in Canada. He knows everything about space, about solar storms, about comets blowing up like the one that happened in Russia. And without further ado, my absolute favorite astronomer for all your questions and answers this morning about what's up there.
Gary Boyle. And wouldn't we like to leave this Earth around now and do something else?
Yes.
Anyway.
I would volunteer Gary for the next NASA mission.
Hello, Gary.
No, why not?
I don't want to go up on a bomb and come down as a flaming marshmallow. There's no way. There's no way I want to stay here on Earth. Speak to you lovely people.
Oh, so let's talk about how you got into astronomy in the first place.
Well, it started many, many moons ago, back in 1965. I was starting grade 2. In fact, my whole career started in Verdun. I was born and bred in Verdun. And starting grade 2, meeting my friends, what we did after summer vacation, went to the library, and came across this book entitled Stars. It's not the book, because the fees would cost me a fortune, but there's a paper copy a friend gave me years and years ago for my birthday. And just turning to a page that showed how small the Earth was compared to the sun. In fact, you can fit 109 Earths across the sun, and 1.3 million to fit inside our daytime star. So as an 8-year-old, that was my wow factor, a fish out of water. I've never stopped for the last 60 years.
You know, when I was a kid, my dad used to take me, we were living in Ottawa, and my dad used to take me out to my grandmother's in Pakenham, and there was a farmer's field, and that was the first time I saw a night sky without any light pollution. And it's absolutely spectacular. And I would see shooting stars, but then I discovered, because of course I watch a lot of videos, that sometimes those shooting stars get a little bit close. I'd like to talk about the Chelyabinsk event in 2013, and then of course the Tunguska event, where meteor bolides just got really close to the Earth.
Yeah, that was early in the morning. It was just after 9 a.m. local time, so the sun was up. It was a clear sky, and there were a lot of dash cams and on cars, on security cameras.
That. Yes.
And they saw this huge flash come across the sky. Well, it was really the size of 1.5 school buses in length. And what it did is the bolide really exploded in air. But the downward rush, which actually caused meteorites, and this is a true meteorite from space, which they found later, but the downward rush of the pressure actually injured about 1,500 people from flying glass, because people went to the window. They saw this flash in the sky, go through the window a few seconds later, bam, the glass flies in. And even security cameras showing garage doors being blown in, people flying. So this really, really hit. So it's a good thing that it did not hit the ground, explode in the air, but a lot of these things did hit the ground.
And why do we call it a bolide as opposed to a meteor? And then we're going to talk about, of course, the most famous one in 1908.
Yeah, a bolide really is a meteor that explodes in space. Usually what they do is these things, they break apart. So when we have something maybe the size of a desk, a bathtub, something smaller, basketball, as it comes down, it's very bright. I mean, it lights up the sky at night for sure. We call these a fireball. But as they burn up, these pieces they fly off and then they hit the ground. But a boloid explodes. It just breaks apart. And then you get that explosion, you get the sound wave. In fact, it happened on the West Coast a couple of weeks ago, where it was so intense the sound even set off seismographs. So it must have been really something to hear that wonderful event.
But
Do
the
you
one
get
in
this?
Russia. Oh,
I'm
go
sorry.
ahead.
No. I was wondering. I'm zigging while you're zagging here. Do you get? Have you seen these pieces of bits that have fallen through? Have you touched them in your career, your passion so far?
Well, this is a true meteorite from space that I bought off one of our members from the Royal Astronomical Society of Canada. And this was when that landed, I believe, in Africa about 500 years ago. So yes, I am touching, and I actually bring this to show and tell when I do a lot of senior lectures, go to schools too. So yeah, these are really meteorites. And I have seen a couple of bolides in the past where you get that fireworks in the sky where it just explodes. It's really something to see. And it's nothing that we can really predict. We see shooting stars every night during meteor showers, which we'll talk a little later on, more per hour in the tens or hundreds per hour, in fact. But when these things occur, it's just anything really falling through the atmosphere and can be very bright that leaves a shadow on the ground. So keep looking up and you're bound to see something. The Earth gets about 100 tons of meteor debris every day, mostly in the form of the dust as it's blazing through the atmosphere. But some of these things do hit too.
100
I was
tons.
reading, I saw this, my favorite ever bolide was, of course, the Tunguska bolide, which is in Siberia, I believe. And that was a big one. It was in 1908, and it flattened, literally, Yvan, kilometers and kilometers and kilometers of trees. There were miners who
I
said
remember
they
seeing the
saw
photographs.
light.
Yeah.
Yeah. And people who were near actually got a kind of a sunburn.
Exactly. Yes. Unfortunately, I don't think anyone died. There were animals, of course, that got cooked from this fireball, and yeah, trees were flattened like matchsticks for tens of kilometers, all in one area. And this was only a 50-meter wide impactor. Again, that exploded downward rush. There was no crater found, and even a few trees that were right below the impact stayed up, but the branches were of course knocked down. But other than that, it was like blades of grass. It must have been really something to see, not knowing what it was, but we now know what these bolides really are. And I've seen, like I said, a few in the past at night, but to see even during the day, because this did occur June 30th, and it was during the day, so it must have been a spectacular event.
Now you have an observatory at your home, yes?
Correct. Yes. In fact, I had one when we lived in Barrhaven in Ottawa, suburb of Ottawa. It was a smaller 11 by 9 foot. That's all I can fit in the backyard. But now that we're here in the countryside, built a bigger one, 24 by 12 feet. It consists of 2 rooms. One has 2 telescopes in it. On the other side of the wall is a completely insulated control room. So it'll be nice and warm during these wonderful Canadian winter nights. And the whole 12 by 12 roof rolls off to one side. So it's a dream come true to actually have a larger one under wonderful country skies.
I was going to say light pollution, less of a problem there, I presume.
Oh yes, for sure. In fact, on clear nights, see the Milky Way. Even in wintertime, to the left of Orion is where you can see the Milky Way, but it's the outer part of our galaxy, the end. In summertime, which is rising now, Scorpius, Sagittarius rising around 3 or 4 o'clock in the morning, and as the weeks go on, will rise earlier, is where the heart of our galaxy really is. And that's why we see the beautiful, long collection of some 400 billion stars of our Milky Way.
And the instrument you have must be probably not something you ordered from Amazon, I presume?
No, Amazon do sell these things, but it's expensive research-grade telescope. It weighs 85 pounds, so it's not really transportable, but it's completely computerized. And if anyone wants to buy telescopes, really do stay away from big box stores. That $200 telescope might seem like a wonderful steal and deal, start the car, but you'll be in next week's garage sale for sure. So do your research, and people can always reach out to me on wonderful places in Canada and the U.S., reputable telescope dealers.
Okay.
And I made you send some pictures of your telescope. And the amazing thing about you. I know you're a member of the Royal Astronomical Society? Oh, there it is now. That's a biggie.
Is this the instrument we're seeing here, Gary?
That's correct. Yes, that's my large instrument that I'm hanging on to, and my friend Joe is on the right hand side, and that's with the roof fully open with winches because it weighs a few hundred pounds.
Wow.
But once you open up, the sky is the limit, literally.
Okay. And I'm curious about your daily routine then. Is this a daily observational routine that you have? You have your espresso in the morning and then brush your teeth and you get out there and start looking around?
Well, not in the morning, unless I'm doing sunspots, which I have imaged sunspots in the past. But if the sky is clear and if it's not too windy, because you don't want a roof flying off, that's not a good thing. Yeah, during clear nights, I can be out there. Retired now, just living the wonderful life. And this, by the way, is the smaller observatory that I had in Barhaven years ago.
But it's the same instrument we're seeing in the other photograph, is it?
Yeah, this is a 12-inch me telescope. The other one, the previous image, is a 10-inch. But they're both electronic, research-grade instruments that are just a wonderful treat to have, but a little on the expensive side.
Okay, this is not something that the average person would perhaps spend on, but
well, you could, depending on your flavor,
on your budget, yeah,
on your budget for sure. And that's one thing I was doing an astronomy day demonstration we had here in Ottawa, and someone had a smaller scope like this, an 8-inch, and someone came by that was from Calgary. And asked how much the telescope was, and I said, this one's about $4,500. $4,500? Yada, yada, yada. I noticed that he had a package of cigarettes in his pocket. I said, oh, by the way, how much are cigarettes back in Calgary? It's like $12 a pack. I did the calculations, and you couldn't believe it. After 1.5 years of smoking, you could own that telescope.
wow.
I've had telescopes here for the last 50 years. So as long as you take care of it, you'll have forever.
Okay, we have other photographs here too. I don't know if you want to start. We can look at this now. You'll have to guide us through these.
Well, this is the Andromeda Galaxy. It's the closest, brightest object we can see with the unaided eye. In fact, in late
The
summer...
unaided eye, you say?
Unaided eye, yes. Naked eye. Naked eye,
wow.
Yes. If you're, especially in August, when the galaxy is pretty well straight up in the sky, you know where to look. And I've done this many times when I do star nights at Algonquin Park, showing people with my green laser pointer, and they see that little blotch in the sky. That's the Andromeda Galaxy, 2.3 million light years away. And that's when Homo habilis was starting to walk the Earth, even before Homo sapiens. It takes a while for light to reach us, even at this great distance. The moon is 1.3 light seconds away.
Wow. And this,
and by the way, and that galaxy has about 1 trillion stars in it, compared to the Milky Way that has about 400 billion stars.
Wow.
Okay. And this is
Beautiful.
A meteorite?
Yeah. Nope, that's a comet Neowise.
A comet. Okay.
Comet. We do get comets every now and then. Now, astronomers can see maybe 5, 6 comets throughout the year, but only in telescopes. Photographic, really small to see, hard to find, but every now and then, every 10 or 20 years, you get these beautiful naked eye comets. Again, you don't need anything to really look at it. And this was throughout the month of July of the year 2020, where I was just moving across the sky over the nights. A wonderful thing to see. And everyone around the world got to see this, the thousands of pictures that have been shared on Facebook. And it's events like these that really drive people out of the house, away from the 3 T's, I call it: the telephone, the tablet, and the TV. So really, the sky is a wonderful classroom, and it's these events that really bring people out and want to learn more. Nowadays, astronomy is, you don't need the PhD or $8,000 of equipment, just simple binoculars, let them know how by our apps on our phone. Away you go.
Okay. Difference between a comet and a meteorite. You see how much I know?
Well, first of all, a meteor, as I showed you, is one that really flashes in the sky.
And a meteorite is a piece of a meteor?
It decides the meteorite when it hits the ground. Most of these burn up in the upper atmosphere. Mm-hmm. But then a comet really are kilometers across. It's really an asteroid, 10, 15, 8 kilometers, they're all different sizes, that have a lot of frozen chemicals, frozen water ice, that when the comet comes from far past Pluto, around the sun, now the solar energy is interfering with the comet, begins to break apart a bit, new energy is or gases are released, and the comet glows. And that's why we see comets. So really, if you don't want a comet hitting the Earth, ask the dinosaurs 66 million years ago, where an asteroid about 6 miles or 10 kilometers did hit the Earth and killed about 80% of life on our planet. So the dinosaurs didn't have a space program. We do.
Do you look down occasionally too? Are you as fascinated by impact craters and the like?
I'm interested in everything. It's great to know the history, such as what happened in Tunguska. We had the Barringer crater in Winslow, Arizona, that occurred 50,000 years ago. And again, that was only 50 meters across and made a crater over a kilometer wide. And then even in Quebec, the Manicouagan crater happened 214 million years ago, 5 kilometer wide impactor, and created a crater about 100 kilometers in diameter. So that really is a meteorite impact.
Yeah, I was thinking about that because I was born in the Sudbury Basin, which was formed by the impact of a large object many millions of years ago. And it probably explains a few things about me, but never mind that for now. What else have we got here?
I didn't know that about Sudbury.
Oh, yeah, it's that's where all the nickel is because this big thing hit a long time ago.
And that's the element that it probably deposited more of, because all these meteorites, all these asteroids are made of all the elements on the periodic table. All the elements that we need for life, the carbon, hydrogen, oxygen, nitrogen, and everything else comes from stars that died off billions of years ago that make new stars like our sun, and we have these elements. So nickel was probably incorporated in that asteroid that it hit a long time ago.
Copper, and this is a shot of something. I presume this is our moon.
That's our moon. This crater is called Clavius. I love Clavius. It's in the southern part of the moon. And what I love about it is you get that large crater, and then inside it's smaller and smaller and smaller. Just that nice ring. Images I see on TV, these images here, videos, do not replace looking through the eyepiece of a telescope. Whenever you can, a lot of the centers of the Royal Astronomical Society of Canada have these sidewalk nights where the public can set up either outside, a bookstore or a shopping mall or something to really, come see the moon, come look at a planet. It's a great time to look through a telescope. And once you've seen the moon through the eyepiece of a telescope, the blacks are blacker than you would ever imagine.
And this is a shot from your instrument?
That's correct. Yeah, that first one I took in Barrhaven. Yes, that's the kind of resolution that you can get.
Amazing how close you can get.
But again, you don't need telescopes this size. Any telescope will show the moon, will show planets, even the rings of Saturn. So don't be disparaged if you think you need that $10,000 instrument. Mine's not that much. But something as small as a few $100, a Dobsonian mount, is what will get you going. Well, this is the belt stars of Orion the Hunter. And it's a wintertime constellation. People, I'm sure, have noticed this when they walk outside. This beautiful, it almost looks like a stop sign in the sky. That's about the size of Orion at arm's length. And it depicts a true hunter in the sky, the two stars of its shoulders. These are the three stars of its belt. And down below is the imaginary sword. And there we have the Orion Nebula, which we call a stellar nursery. And these are where stars are being born. It takes a few million years. And it's estimated a couple of thousand stars will come out of this nebula, but over a long period of time.
And how long ago? Because you talked to me last week about that. What we're seeing now happened some thousands of years ago, right? For the light to
Correct.
Now.
Yeah, the Orion Nebula is actually 1,500 light years away. Now, a light year is the distance that astronomers use, like a yardstick, meter stick, your ruler. But the numbers would be off the charts if we kept using kilometers from here to the next star. So we use light years. Imagine the speed of light is 7.5 times around the Earth in 1 second, traveling in a straight line for 1,500 years. Traveling a straight line to the Andromeda Galaxy for 2.3 million years. And I've seen galaxies up to 300 million light years away in my telescope.
Oy, this is a great shot here. I got to start looking up more.
Yes.
Yeah, this is a conjunction that we had of Jupiter, of the moon. Just below that is Venus, and then just below that is the star Regulus. So it's a beautiful lineup, which we call a conjunction. That was a few months ago in the eastern sky. And really, the moon is a wonderful thing to use to find planets. Now, our apps on our cell phones show you have so many free apps nowadays that you can download that shows where the planets are at any given time. But for this get on air and say, Jupiter will be next to the moon tonight, look for the moon, you'll find Jupiter or Saturn or Mars or any other particular object. So the moon is a wonderful guide to show these objects in the sky. And we do have a bright planet nowadays. Look directly up, just to the upper left of Orion. You can see a bright star. That is the planet Jupiter.
Wow. And
Another
this is
nice shot here.
Shot.
Of the moon, of course, yeah.
This was a very lucky shot. When I say I had my ducks in a row, I had the geese in a row. I had no idea that they moved in the field of view. What I was doing is I was changing the aperture on my lens to make light or dark and just clicking my cable release. And just click, 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 click. Then after when I looked in the viewfinder on how the images came out, I noticed this dark area. I zoomed in, and there were the geese. A tenth of a second before or after, I would have missed.
Amazing.
Another nice shot here, too. It's amazing how large it looks at times.
It does. This is taken with a 300 millimeter telephoto lens, which I got to crop. That's when you put in Photoshop and bring down the image, you crop it. But just through the trees on a regular tripod. So you can do a lot of moon work, lunar work with just a regular tripod. You don't even need a telescope. So there's a lot you can do without the expensive instruments. As I said, I started off in Verdun. Many nights would find me look at the stars, having my charts to memorize the constellations. And that's the wonderful thing you start with astronomy is memorizing those starry patterns, such as we all know the Big Dipper, Orion the Hunter, easily found. It won't occur overnight, pardon the pun, but you will learn the constellations. Just like a song that you heard for the first time, say a country song or Taylor Swift, you might remember a couple of words. But after the 20th, 30th time, you have remembered all the lyrics. Happy birthday, traditional Christmas songs, we know all those words. Once you really associate with the constellations, they're no longer random dots. Now we have ordered to the mayhem up in the sky.
And this is a shot through your scope, I presume.
No, that's another telephoto lens. Well,
Really? This is a camera shot?
It's a camera shot, yes. Yeah,
wow.
This one was through the telescope, yes.
Oh, okay.
Prime focus. And seeing the thousands of craters. These are the seas or the mare of the moon. We don't see the man in the moon here, the fictitious man in the moon that looks like. But these are seas of lava. When the moon was created from a small baby plant that hit the Earth more than 4 billion years ago, it created the moon out of the lava that was moved out from the Earth and of this baby plant called Theia. So the moon is giving off a lot of volcanoes, a lot of lava. In fact, there's so much lava that came out of the moon, you can cover the entire USA a quarter mile thick. So these are just dark mare of cold lava.
Wow.
Another shot of the surface here. This is again, I presume, through the instrument. Yes.
Yes, high res image of a crater over here, and again, it might look good on images, but to see this live, to see the shadows, to see the very peaks of sunlight coming across the shadows that's still in darkness, which we call the terminator, that dividing line between light and dark. And just to give you a little perspective on the moon, there's no atmosphere in the moon, although the flag seems like it's waving by Apollo. It's not. It's they had a curtain rod above it. But on the left part of the moon, it's about plus 250 degrees Fahrenheit. And on the shadow side, minus 250 degrees Fahrenheit. So you have these huge temperature differences.
Now, I have seen, how would you refer to this? A star field, I suppose?
That's right, yes, a wide angle star field.
Okay. I've seen this in areas where you're where there's no light pollution and you can't see your hand in front of your face, and then you look up and you see this. It's quite astounding.
It is, and this is my backyard. I took that from the deck looking south towards Sagittarius. This is in the constellation of Scuti, the Scuti star cloud, and you can see toward the bottom right of the photograph, the heavier concentration of stars. So as I said, our galaxy has an estimated 400 billion stars. Well, what's 400 billion other than Elon Musk's bank account? If we took a regular grain of table salt to represent a star, you would fill a sandbox 22 feet by 22 feet by 1 foot high just for the Milky Way. There are an estimated 2 trillion galaxies in our universe, which numbers could be 10 or 20 times that. So you're just seeing that they not just dust, but stars behind stars behind stars.
Wow. Gorgeous.
Thanks.
And here we have a shot shooting stars. Yes.
Meteor shower?
Meteor shower is taken from Joe that has his telescope in the observatory too. He came out one night and he loves more photography. I do photography too, but I'm actually learning off of Joe. He's got the real good techniques. And this is really a composite. Now this is taking many images. I think these are like 30-second tracked images. He has a tracker. And then puts them all together. You stack them all together like pages in a book. And then so it's not just one image, but many images all together. And yeah, that's from the Perseid meteor shower.
Stunning.
Now this one here.
Oh.
Well, the Orion the Hunter, the sword that comes down, that patch of gas, which you can see even from Montreal, all the suburbs. Look down the sword handle, you see that little patch that is the Orion Nebula. More closer view taken through the telescope, where stars are slowly being formed as we speak.
Neato.
Insane. And these are northern lights, yes?
Yeah, that was back on May 10th of 2024. We had huge solar storms and gave us a wonderful aurora display. So the KP index that you probably see on spaceweather.com, as the higher the number, the lower in latitude it gets. So it's a KP7, KP8. We're going to get it, especially from Ottawa, Montreal. This was a KP9 they saw down in Florida and Puerto Rico that don't see auroras too often. So we see the beautiful greens and purples, blues. Well, the greens and reds are the oxygen molecule that's being ionized, and the purple and blues are the nitrogen, because our atmosphere really is made up of 78% nitrogen and 21% oxygen. We don't breathe true oxygen in the atmosphere. Medical devices have about 99% in their tanks, but what we breathe nowadays is mostly nitrogen.
And this has not been retouched or fiddled with in any way?
No, it hasn't. No,
Okay,
it hasn't.
I'm not accusing you of anything, but there's so much slop out there these days.
That's so gorgeous.
Now, wait a minute. And I was reading here, you have an asteroid named after you.
That's right. Yep, right here. Asteroid 22406, Gary Boyle. It's
Gary
not
Boyle.
It's not something that I found, but it's an award given like the Academy Awards, a Grammy, on recognition of what you've done. And asteroids are given to various genres, not just astronomers. It could be teachers. Mozart has an asteroid. Florence Nightingale for nursing back in the 1900s. She has an asteroid named after her. So really, it's just the work I've been doing in astronomy, the outreach like we're doing now, since 1995. And I was awarded this in 2017, the same date as my wife's birthday. So we were really celebrating that day.
Nice.
Okay, and this outreach program, it's you go out and you lecture, you talk to classrooms, I believe, and others?
Yes, I go to schools, mostly grade 9, because there's astronomy in grade 9 here in Ontario, not sure about Quebec, to inspire what the beauty of science really is, especially on astronomy, my field, my passion, and just to stay in the field of science. Because the generation today, the grade 9 students I speak to, will probably stick with science. In 20, 30 years, make the next huge discovery, no matter what it is, in astronomy, medicine, engineering, all stemming from what they see today. Or if I get on air saying, look at the meteor shower or the the blood moon, the total lunar eclipse we had a few weeks ago in the West Coast that was seeing the entire event. That might inspire that 10-year-old, as I did, starting with the sky, and might pursue to who knows what is in the future. So science is a wonderful thing. No matter if you're smelling flowers, listening to a songbird, or look at the stars. It's a beautiful thing to behold firsthand.
Now, as you know, they've switched a lot of our stuff to from analog to digital now. Now, I remember a few years back, there was an event where, and you're going to correct me, I know this, but it was a magnetic storm caused by a solar flare, and I know sometimes those are so big that pilots will actually fly below the 30,000 feet because there's a lot of radiation. But we have had solar flares, magnetic storms that have actually taken out grids. So, and I think that's going to lead me next to the Carrington event. But let's talk about how solar flares and magnetic storms can take out our electronic grids.
Yeah, the sun is really does what the sun wants to do. It has these hissy fits every now and then. And we have a solar maximum, which we're at now, and a solar minimum every 11 years, from peak to peak. And what is the sun being as large as it is, over a million Earths fitting inside, or 385 fitting like a belt around, to give you a perspective, it's just a ball of gas, ball of plasma. It doesn't turn like the Earth does. So inside the sun, it's turning at different rates. At the pole, at the equator, about once every 25 days. At the poles, once every 36 days. So after a while, you get the magnetic fields are twisting like spaghetti. Like taking out the Christmas lights, it's in a ball, and you got to unravel it. Well, these loops now are protruding above the surface of the sun, which is a gas anyway, and making these sunspots. That's why we're seeing a lot of great sunspots now. And now it's releasing all this energy when spots come together, like take two wires and you get a short circuit. Then we get material that flies through space. It takes about 3 days to reach the Earth at 150 million kilometers. In fact, by the way, I just checked the solar winds right now. We're 536 kilometers per second. And that's about an average speed of the sun. So every now and then, it gets really heavy storms that hit the Earth. And what it does, our magnetic field that protects our planet, there's not enough to hold it back. Some of the charged particles bleed in and then mix in with the poles. We get beautiful northern lights. But then they can really give us these magnetic storms. The geomagnetic storms, around the four, we get wonderful auroras, but they can deplete or interfere with electrical grids. And this happened back on March 13th of 1989. My wife and I were living back in Montreal. Power grid went down because of the way how Quebec has indigenous rock. It really just could not take in the power. But as you said, for the Carrington event, it was not that close, but we're at the whim of the sun. It can happen anytime.
Are you as much of a fan of space exploration and rocketry and all of that as you are of astronomy?
Oh yes, definitely. I'm all gung ho on everything because really space exploration is technology. Now I grew up in 1957, the year of the Chevy, and in October of that year, Sputnik went up, and the year after that, NASA was incorporated. So I've seen the whole space program move through Apollo. Yes, we did go to the moon. To what we have satellites, so now we even have the Parker Solar Probe going around the sun a few million kilometers away from the sun. Don't forget the sun's 150 million kilometers from Earth. So to see the advancement, and it's not just pretty pictures of stars, it's really technology. There are a lot of spin-offs from NASA that we have nowadays that came down the pipe because of the ongoing technology. The Dustbuster, not that they had, really, really messy spacecraft, but, we have wireless or tools that we don't need power cords. And when they work outside the International Space Station, all these cordless power tools that we all use nowadays. Grooved runways, so cars don't fly off the highway. We use that nowadays. That's to keep the shuttle when it came down. So many others. De-icing of planes. There's just a huge list of spin-offs because of technology, and more coming. Everything too is LASIK surgery. When the space shuttle, and even nowadays, When the Dragon spacecraft is moving up to the International Space Station, they use that laser to guide it. LASIK surgery came from that technology.
What do you think of this of Artemis coming up, this space mission to go? Are they going around the dark side of the moon?
Yes. Dark side is really the far side. There's no dark side, because anytime the moon or the Earth is going around the sun, there's always one half of the sphere that's lit, and the other part is in darkness. So it's the unlit side. But yeah, they'll be going around a few times and coming back. Now, we're supposed to have the launch back on March the 6th, but it's been delayed now until all days April Fool's Day. It's not a joke, with the other days going from the 2nd to the 6th. So there's a window to have them go to the moon. Artemis 1 was a completely autonomous mission. They went by robotic. They went past the moon, came back, no problem. No problem, but they did notice in the heat shield, there were cracks in the heat shield, and even little pieces of the heat shield were missing. So this is a concern for sure. The wonderful thing about Artemis 2, although they won't be landing, is our first Canadian astronaut, Jeremy Hansen, will be on board. They'll go around the moon a few times and come back. Artemis 3 now was supposed to land in 2027, but now that has been moved back. They will be rehearsing, meeting spacecraft sort of thing in Earth orbit. Artemis 4 in 2028 for now will be landing on the moon.
Wow, so cool.
Any stellar or planetary events to look for in the coming weeks that have you kind of ticking off your calendar?
Well, we have, like I said, Jupiter. If you look up straight tonight, everybody has homework out there, look up tonight, and you have Jupiter in the western sky, slowly moving up as the weeks go on, as the months go on. We have the planet Venus, even brighter than Jupiter. And the two will be close together in the first week of June, which I call the spooky eyes. Two brightest planets of our solar system together. I call spooky eyes, if you remember the old Bugs Bunny cartoons, when they were in the cave and the eyes would just light up in the cave. These two planets do that. And it's really something to see. We do have the close approach of Mars in February of 2027. And Mars takes longer to orbit the sun, 687 days compared to the Earth's 365 and a quarter days. Quarter day, because we actually orbit 6 hours longer each year, which means that every fourth year is that extra day, our leap day, February 29th. So every 26 months, Earth and Mars come close together, and that'll occur in February. Then we can see greater detail. The planet will look brighter, almost as bright as Jupiter, which will be close to the planet around this time next year.
And what showers are we looking forward to?
And meteor showers, yes. In this month, we're going to have April 22nd, or this next month, that is, will be the Leonids. Semi-decent shower, maybe about 10 to 20 meters per hour, maybe 30, nothing great. The next one will be the Eta Aquarids, on May the 4th, Star Wars Day, May the 4th be with you. That'll be about 50 meters per hour. But the best meteor showers of the year are the Perseids, summertime, August 12th, people at cottages, campgrounds. By the 80 to 100 meters will be seen, and that's the same day as the total solar eclipse, so the moon will not interfere. And then in December, don't want to think about winter, let's get rid of winter this year. On the 14th of December are the Geminids, at 120 meters per hour, this slow, graceful, a real wonderful event to observe. But any night when you're looking up, you're bound to see satellites, meteors, could be space junk, but still something is always happening in the sky.
Outstanding, Gary. Is there a website where we can look you up and get more information about you? And are you still doing speaking engagements and the like? Yes.
I sure am. I do a lot of lecturing. In fact, I do about 70 in-person lectures per year, mostly at senior homes and some schools. And so contact me if you wish. Thank you for the plug. Thank you for the commercial. My website is wondersofastronomy.com, and anyone can email me their questions. Telescope, what they see in the sky. Again, telescopes, as we mentioned, stick away from the big box stores. I can always guide them to a particular website. and the type of telescope which is good for them in their budget.
I have just one.
Wondersofastronomy.com. Sorry, Era, continue.
Say that again. Sorry about that.
Wondersofastronomy.com, and we'll put that up on the YouTube description, of course.
I just have a question for you. What are the chances of having a big storm that could take out all the power on Earth? Like 1 in a million, 1 in...
It could happen. The solar.
I can
solar
think of a
map-
name for it right now. I won't mention it, but please continue.
Yeah, it's actually called a Carrington event that occurred back in 1859, the night of September 1st and 2nd. And that was a solar storm, an S5 storm. If we had an S5 storm now, if you're in a commercial airliner, you get the equal to 10 chest x-rays. That's how much radiation. Back then, the only way to send messages was through the telegraph. And this is when you have batteries on either stations that would send electrical currents across the lines. They're able to unhook the batteries and still send messages through. That's what the sun really did. That can happen anytime. We're at the rim of the sun. As you can see, the size of the sun compared to the Earth. We're in a shooting gallery of meteorites and space radiation.
We could go on for hours. Gary, thank you so much for your time.
Well, thank you for having me. I love to do this. Love to explain the wonders of the nighttime sky. It's a beautiful pastime that you can do yourself, the family can do. There's so many tools, as I said, nowadays. Your apps on phones, telescopes are coming down in price. Binoculars, the best way to start. And again, many sources online which you can reach out and learn the wonders of the nighttime sky.
Binoculars are the best way to start. I will note that. Thank you.
Thanks, Gary.
Thanks, Gary. That was terrific.
Thank
you, sir. It was a pleasure. Thank you.
Let's do this again sometime. Take care.
Thank you.